You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome back. We've been digging through a whole stack of the latest material on data, AI, and machine learning. Our goal, to pull out the key insights so you can stay informed without drowning in information.
Yeah, absolutely. And today we're looking at, well, a real mix. Some very practical tools and applications, a big emerging skill, and, some fundamental changes in how we actually handle data in this AI era.
Okay, let's jump right in then. There's this term gaining traction being called, get this, 2025's #1 skill in AI. Sounds significant. It seems to go beyond just writing good prompts.
It really does. We're seeing a move from standard prompt engineering, which is often quite static, to something much more dynamic. It's being called context engineering.
Cox engineering.
Yeah. It's less about just the prompt and more about architecting these smart context pipelines for the large language models, the LLMs. So you're not just asking the question, you're designing the whole information environment the AI uses to answer it.
Designing the environment.
Yeah.
So engineering the AI's worldview almost. Does that mean totally new skills or building on what data teams already do?
It's definitely an evolution, a more rigorous engineering approach. Think about things like selective RAG retrieval. That's retrieval augmented generation, making sure the AI only pulls in the truly relevant bits of information.
Right, so it's not overloaded.
Exactly. And context compression, shrinking that relevant info smartly to fit within token limits, plus ensuring the output is structured so it actually plugs into other systems easily. The big payoff here, you drastically cut down on those AI hallucinations.
Hallucinations.
And you optimize costs and speed. It's really about making LLMs ready for serious production use.
Okay, that makes sense. Reducing hallucinations, better performance. That's crucial. But speaking of performance, what about the raw data processing? Many of us still hit bottlenecks with, just big tables of data.
Well, that connects perfectly to the next thing we're seeing. GPU acceleration is just completely changing the game for standard Pandas workflows. Honestly, the numbers are kind of staggering.
Oh, yeah.
We're seeing performance boosts like up to 30 times faster on large data sets. This is using tools like NVIDIA's CutEF. It's basically Pandas, but running on your GPU.
30 times. Wow. And does that mean rewriting all my Pandas code? Because that's usually the catch.
That's the beauty of it. Often it requires no code rewrites. You can take existing Pandas code and, with minimal changes, run it on the GPU for that massive speed up.
No code rewrites. That is a game changer. So this makes high-performance computing more accessible for, everyday data analysis.
Absolutely. Suddenly, analyzing huge time series stock data sets or processing, thousands of text-heavy job postings or building interactive dashboards that don't lag at all becomes much more feasible, even with enormous data frames.
How does that work if the data set's bigger than the GPU memory?
Well, things like unified virtual memory help there. It lets the GPU sort of seamlessly dip into the main system memory when needed, so you can tackle data sets larger than the GPU's own RAM. Pretty neat stuff.
Okay, so we've got smarter context for AI and super fast data processing thanks to GPUs. But where does all this data live? Especially the kind AI needs. Are traditional databases keeping up?
That brings us right to another major shift, the rise of the AI database. And these aren't just, slightly updated versions of what we had. They're fundamentally new platforms.
New how? What makes them different?
They're built to unify things that used to be separate. So you get your standard relational data management, but combined with vector search, which is crucial for finding similar items like in recommendation systems and full-text indexing, all in one system.
Relational, vector, and text search together. Okay, I can see how that simplifies things. So the main benefit is streamlining the tech stack for AI.
That's a huge part of it, yeah. It makes developing AI services much faster and cleaner. Think about building chatbots that need structured user data and semantic search over documents, or recommendation engines, or real-time fraud detection.
Right, those often need different types of data access.
Exactly. This unified approach just smooths out the whole development process for those kinds of real-time AI applications. It brings all the pieces together efficiently.
Okay, fascinating. So the infrastructure is evolving rapidly. Let's pivot to the people using all this. How are developers actually, using AI day to day? What's the real impact been so far?
Yeah, there is a really interesting survey from Atlassian on this. They found that, get this, 68% of developers are saving over 10 hours a week using AI tools.
10 hours. That's significant. Is that mostly AI helping them write code faster?
Well, here's the interesting bit. The biggest time savings reported were actually from non-coding tasks. Things like generating documentation, writing summaries, maybe drafting emails or reports.
Ah, non-coding tasks. That's really telling, isn't it? So AI is helpful, but maybe not yet cracking all the core developer workflow problems.
Precisely. The survey also pointed out where developers still feel friction, areas where AI could potentially help a lot more.
Like what?
Things like just finding information, navigating scattered documentation, finding the right API, understanding different microservices, also getting up to speed with new technologies, and just the constant mental load of switching between different tools and contexts.
Yeah, that context switching is a killer. So lots of potential still for AI to smooth out those developer pain points.
Definitely. There's still a lot of room for improvement there.
Okay, well, we certainly covered a lot of ground today. From engineering the context for AI thinking to massive speedups in data crunching with GPUs, new unified databases, and, well, how developers are actually saving time, mostly outside of coding itself. The pace is just incredible.
It really is, and it makes you think, doesn't it? With all these advancements, how will our whole idea of data-driven decisions change? When AI isn't just a tool we use, but maybe more of an active partner in how we find and interpret information.
That's a deep question.
What new questions should we be asking? Not just querying our data, but questioning the AI systems themselves, how they shape the insights we see.
Definitely something to chew on. A great place to leave it for today. Thanks, as always, for joining us and exploring these changes. Keep learning, keep experimenting.
Absolutely. Until next time.
Spoken Tech for your ears.